Hello, welcome to all to my YouTube channel. This course is mainly designed for joint entrance main, advanced, AITPL, and all other engineering entrance examinations. So, before starting my class today, you are all requested to subscribe me and stay connected with me. Okay, here some of problems for all of you. The first problem is the number of terms in x plus 1 plus 1 by x whole square is 301. Okay, there are number of terms here is 300 is 1. Then n is greater than, we focus that n is greater than which of the following values here. Here also define that n belongs to capital N, that is set of natural number. So we solve this first. Okay, here we see that the problem is x plus 1 plus 1 by x whole square. Okay, we expand this first. First we expand this and then solve the problem. So we first here uh, take the LCM and solve the problem. So we may write this as 1 plus x square uh, divided by x to the power in here. I have done a mistake for writing the question here, that is here small n. Okay, now we have 1 plus x square whole to the power n. Surely is of the form here, that is a suffix 0, a1x plus a2x square and so on to a2n x to the power 2n. Okay, surely this contains 2n plus 1 terms. So 2n plus 1 here also given that 301, that is 301. Okay, so 2n here 300, n here 150. So surely that n is greater than the option is 149 here. Okay, 149. As n is 150, so 150 greater than 159 here. This is the answer here. The option here 151. Okay, if you any doubt, you may comment me in my comment box. Okay, this problem is very easy, so take it seriously to solve this question. Next, the question, if x plus 1 by x equals to 1, and here the lambda to the power 4000 plus 1 by lambda equals to x to the power 4000 plus 1 by x plus 4000, and mu be the digit at unit place of the number x to the power 2 to the power n plus 1 here, plus 1, where may write 1 here, where n belongs capital N, that is set of natural number, and n greater than 1, we have to find lambda plus mu. So first we write x plus 1 by x, that is equals to 1. So x square minus x plus 1, that is equals to 0. Seriously, the roots of this equation are complex number. So here we just factorize this. We get, after factorizing, x plus omega plus x plus omega square equals to 0, where omega is the cube root of unity, cube root of 1. Okay. Also omega cube equals to 1 as 3 root omega, that is equals to 1. So omega cube equals to 1, and 1 plus omega square equals to 0. You know that. You learned from this in the earlier classes. So we get x equals to minus omega square. Okay. Now we find the value of lambda here. Then lambda equals to minus omega. First we consider x equals to minus omega to the power 4000 plus 1 by minus omega whole to the power 4000 here. Okay. Now we get here, that is omega into omega to the power 3999, also omega into omega to the power 399. First we write this as this is even multiple of 4, so this is omega to the power plus omega to the power 4000. Okay, that is here omega cube to the power 1333, 1 omega cube whole to the power 1333, that is omega. This is 1, so any power of 1 is 1, so 1 by omega here. If we calculate this omega, here omega square plus 1, from this we know that omega 1 plus omega square equals to minus 1. 1 plus omega square equals to minus omega. So minus omega divided by omega, that is minus 1 here. If we put x equals to minus omega square, we also get lambda equals to minus 1. Okay. The next step of the problem, for I write here. Okay. For n greater than 1, for n greater than 1, 2 to the power n, that is 4k here. Okay. where k belongs capital N. Okay, now we have to find 2 to the power n 2 to the power 2 to the power n plus 1. So here 2 to the power 4k plus 1. Here 2 to the power 4k equals to nothing but 16 whole to the power k plus 1. Okay, the mu equals to the last digit of unit place. So we have here the last digit should be 6, that is 6, and plus 1, that is 7 here. So lambda plus mu lambda equals to minus 1 plus 7 here, that is 6. Okay, lambda plus mu equals to 6. So here the option C is correct. Okay, next question. We come to the next question here. uh, Here if sigma r equals to 0 to n, sigma r equals to 0 to n, r plus 1 divided by r minus 1, here ncr equals to 2 to the power 6 minus 1 by 6, then n is equal to which of the following values n is equals to. So we write this as r equals to 0 to n here. Here r plus 2 divided by r plus 1 into ncr equals to, we here r equals to 0 to n. If we calculate this, r plus 1 should be written as r plus 1 plus 1, that is 1 plus 1 by r plus 1 here. Okay, okay, this is ncr. So we may write this as if we multiply this, that can be written as sigma r equals to 0 to n ncr plus, if we run r equals to 0 to n, so 1 plus we first multiply n plus 1 here, and sigma r equals to 0 to n, here n plus 1, and here r plus 1, here ncr. Okay, so r equals to 0 to n ncr plus 1 by n plus 1 sigma, here we know that the formula, that is r equals to 0 to n here, that is n plus 1 c r plus 1. Okay, now this is equals to 2 to the power n plus 1 by n plus 1. This is should be 2 to the power n plus 1 minus 1 divided by, not divided by anything. Okay, that is 2 to the power n plus 1 by n plus 1. Okay, into 2 to the power n plus 1 minus 1. Now if we calculate this, that is n plus 1, the LCM, so 2 to the power n into n plus 1 plus 2 to the power n plus 1 minus 1. We calculate this here. Okay, so we take a command 2 to the power n here, so n plus 3 minus 1 divided by n plus 1 here. Okay, this is equals to 2 to the power 6 minus 1 divided by 6. Okay, that is uh, 2 to the power n into n plus 3 minus 1 divided by n plus 1 equals to 2 to the power 5 into here 5 plus 3, 5 plus 3 minus 1 here. We done a mistake here. This is should be 2 to the power 8. This is 8. Okay, divided by 6. So here obviously 6 can be written as 5 plus 1. Comparing these two, n equals to 5 here. Also n equals to 5, that is equals to D, the correct answer. Okay, come to the next problem. Here a to the power 6 plus b to the power 6 equals to 2. Then the maximum value of the term that is independent of x in the expansion of a x to the power 1/3 plus b x to the power minus 1 by 6 whole to the power 9. Here the criteria a greater than 0, b greater than 0. Okay, so let r plus 1 term, let r plus 1 term is independent of x here. Okay, r plus 1 term is independent of x. Is independent of x. So tr plus 1 equals to 9cr a to the power 9 minus r, sorry, a x to the power 1/3 whole to the power 9 minus r into b x to the power minus 1 by 6 whole to the power r. Okay, so 9cr a to the power 9 minus r into b to the power r. Here x to the power, if we multiply x to the power 1/3 with this, that is x to the power 3 minus r by 3. Here also that is minus 1 by 6, that is minus r by 6 here. Okay, here tr plus 1 is independent of x. independent of x. Therefore we get 3 minus, if we calculate this, that is r by 3 minus r by 6 equals to 0. So 3 minus here r by 2 equals to 0. So r equals to 6 here. Okay, now we have to find the term maximum value of the term. So t 6 plus 1 equals to 9c6 e to the power, that is a to the power 9 minus 6, that is 3 into b to the power 6 here. Okay, if we calculate these, that is 84 a cube b to the power 6. Okay, we write here, as we know, am greater or equals to gm. So for a cube and b to the power 6 by 2 greater or equals to square root of a cube b to the power 6. So we know the value of this, that is a cube b to the power 6 here. If we put this, that is equals to a cube b to the power 6. uh, we have given the value a cube b to the power 6, here should be cube, that is equals to 2, that is 2 by 2 greater or equals to square root of a cube b to the power 6 here. So 1 greater or equals to a cube b to the power 6 here into. So here we get square root of a cube b to the power 6 less or equals to 1. This is, that is a cube b to the power 6 less or equals to 1. If we multiply both sides with 84, that is 84 a cube b to the power 6 less or equals to 8. So the maximum value here, the maximum value equals to 8. Okay, the C option is the correct answer. Next, the number of term in the expansion of, the number of term in the expansion of x cube plus 1 plus x to the power 6 divided by x square whole to the power sigma n belongs n is. Okay, we first let sigma n equals to, let sigma n equals to lambda. Okay, now we put here one number 1. Now x cube plus 1 plus x to the power 6 divided by x square whole to the power sigma n, that is whole to the power lambda here. We write this, oh, this is x cube. We write this as 1 plus x cube plus 1 by that is whole to the power lambda. Okay, we may write this as 1 plus lambda c1 x cube plus 1 by x cube plus lambda c2 x cube plus 1 by x cube whole square, and so on to lambda c lambda uh, x cube plus 1 by x cube whole to the power lambda. Right. On expanding each term, that is x cube plus 1 by x cube whole cube, that is x to the power 9 plus 1 by x to the power 9 plus 3 into x cube plus 1 by x cube here. Okay, now the coefficient of x cube and 1 by x cube has occurred in lambda c1 x cube plus 1 by x cube. Okay, hence the number of terms equals to 1 plus 2 plus 2 plus and so on to lambda times, so on to lambda times, that is 1 plus 2 lambda here. Okay, that is 1 plus 2 into sigma n here, that is 1 plus 2 into here n into n plus 1 divided by 2, cancel out. If we calculate these, we have n square plus n plus 1. This is the answer. So the option D is the correct answer here. Now come to the next question, that is 115 to the whole to the power 96 and 96 whole to the power 115 is divisible by which of the following numbers? Clearly here we find that is here 115 whole to the power 96 minus 96 whole to the power 115. So we may write this as 1 plus 114 whole to the power 96 plus 1 plus 95 whole to the power 115 here minus. Okay, now we expand this, that is 1 plus 96 c1 into 114 96 c2 into 114 whole square and so on, minus 1 plus 115 c1 95 plus 115 c2 95 whole square and so on. Okay, if we calculate this, clearly this one and this one are cancelled out because in the middle is negative minus. So calculating these, we get 114, take a common, that is 96C1 plus 96C2. Here 96C2, here 114, and so on. Okay. Minus, we take common from this, that is 95 115C1 minus 1 sorry plus 115C2 into 95 and so on. Okay. If we take common from this 19, okay, here we get 96C1 plus 96C2 114 and so on minus 5 115C1 plus 115C2 into 95 and so on. Okay, bracket here. So this is clearly divisible by 19. So the expansion is divisible by 19. This is the answer. So the option C is the correct answer here. Come to the next problem, that is 5 plus 2 root 6 whole to the power n equals to I plus f here. Okay, n and I belongs, n plus n and I belongs the natural numbers, set of natural number. Here should the capital I. Okay. F is equals to, we have to find the value of f. Okay. We should find the value of not f, actually the I. Solution. We have I plus f plus f prime. F prime here the conjugate of f. This is conjugate of f. So here 5 plus 2 root 6 whole to the power n, and the conjugate of this, that is 5 minus 2 root 6 whole to the power n here. Clearly this is an even integer, so we write 2k, that is even integer. Now we have that is I plus f into f prime, that is equals to 1 plus 2 root 6 whole to the power n into 5 minus, here 5 minus 2 root 6 whole to the power n. So that is 1 whole to the power n, that is equals to 1. We have this. So now 1 is not 1, I plus f into I minus f here 1, that is I plus f equals to 1 by I minus f. So I equals to 1 by I minus f, here minus. This is the correct answer. This is 1 should be 1 I plus f. Okay, this is 1. This is 1. Okay, so the correct answer is this. Here the first is I and second is 1. Come to the next question. The coefficient of x to the power 11 in the expansion of this. Okay, yeah, we should the solution. Uh, the coefficient of x to the power 11 in the expansion of this, that is 1 plus x square whole to the power 4, 1 plus x cube whole to the power 7, 1 plus x to the power 4 whole to the power 12. Okay, here we have to find the coefficient of x to the power 11. So we get as this. If we uh, get 2 here, that is first 0, first from 0, second from 3, and third for 8. So this sum is 11. Again, if we first take 2 and second for 9 and third for 0, this is also 11. Or 4 3 7, that is 4 equals to 11. Or 8 3 0, this is also 11. Okay, so we get the coefficient as 4c0 into 7c1 into 12c2 here. The again 4c1 plus 7c3 into 12c0 plus 4c2 into 7c1 into 12c1. Okay, first from these, second from these, third from these, and uh, and the last one, that is 4c4 here, 7c1 here, and 12c0 here. After calculating this will be 482,140 plus 504 plus 7. So 1113. Here the correct answer. So 1113, the option C is the correct answer. Come to the next problem, that is if the term independent of x in the expansion of this is k, the term independent of x of the given expansion is k. Here Then we have to find the value of 18k. Solution. Here the given binomial is that is 3 by 2 x square minus 1 by 3x whole to the power 9. Let tr plus 1 be independent of x here. So tr plus 1 equals to 9cr into 1 3 by 2 into x square whole to the power 9 minus r into minus 1 by 3x whole to the power r here. So we have get 9cr 3 by 2 whole to the power 9 minus r, okay, minus 1/3 whole to the power r into x to the power, if we multiply this, that is 18 minus 2r into minus r, okay, that is here 18 minus 3r. The term independent of x, that is independent of x, so the power of x should be 0, that is 18 minus 3r equals to 0, r equals to 6 here. Okay. Now t 6 plus 1 equals to k have given. So 9c6 into 3 by 2 whole to the power 3 into minus 1/3 whole to the power 6 equals to k here. So we get 9 into 8 into 7 divided by 3 into 2 into 1 by 27 into 8, 2 cube equals to 8, that is equals to k. So 18k we get here k equals to 7 by 18. So 18k equals to 7. We have to find the value of 18k. So this is the correct answer. Come to the next problem here. Let 1 plus x plus 2x square whole to the power 20 equals to an expansion is given, that is equals to which of the following option. First we here we write first here, and that is 1 plus x plus 2x square whole to the power 20, that is equals to a0 plus a1x plus so on to a 2n plus x to the power 2n, that is a 40 x to the power 40 here. Okay. We just put x equals to 1 here. So 4 to the power 20 equals to a0 plus a1 plus a2 and so on to a40, number 1, and put x equals to minus 1 here. So here we get 2 to the power 20 equals to a0 minus a1 plus a2 and so on to a40. we just subtract 2 from 1. Okay, so we get 2 into a1 plus a3 plus a39, that is equals to a to the power 4 to the power 40 minus 2 to the power 20. Okay, uh, so now a1 plus a3 plus a39, that is equals to 4 to the power 40 minus 2 to the power 20 divided by 2 here. Now here a to the power 39 equals to 20 factorial into 2 to the power 19 into 1 divided by factorial 19. Here calculate this, we get 20 into 2 to the power 19. So a1 plus a3 and so on to a37, that is equals to 2 to the power 19 into 2 to the power 2 to the power 20 here minus 20 minus 20. Okay, divided by nothing. If we calculated this, that is 2 to the power 19, 2 to the power 20 minus 21. Okay, this is the correct answer. So the answer is the B option. This is all for the today's class. This is very much beneficial all of you. So you um, subscribe this channel and stay connected. If you like this effort, please give a like and share it to your friends also. Okay, thank you for watching.